The four main theories I am going to be focusing on are Big Bang Theory, Simulation Theory, Holographic Universe Theory, Plasma Cosmology Theory, Electric Universe Cosmology, Digital Physics, Reality is Information. What is the Big Bang Theory? The Big Bang Theory is the idea that the universe started from an extremely hot, dense point about 13.8 billion years ago and has been expanding ever since. At the beginning, everything matter, energy, space, and time was squished together in one spot. Suddenly, it started expanding very quickly. That expansion created space, stretched out matter, and eventually formed stars, galaxies, planets, and everything we see today. The universe keeps expanding even now, which is why galaxies are moving away from each other. The Big Bang doesn't describe an explosion in space, but rather space itself stretching out. How did the Big Bang occur? 1. The instant of beginning, 0 to 10 to the power of minus 43 seconds. The singularity. Before this moment, all matter and energy in the universe were concentrated into an inconceivably small, hot point, less than an atom. The Planck epoch. At this earliest stage, 0 to 10 to the power of minus 43 seconds, physics as we know it breaks down. The four fundamental forces, gravity, electromagnetism, and the strong/weak nuclear forces, are unified into a single superforce. 2. Inflation and particle formation, 10 to the power of minus 36 to 10 to the power of minus 6 seconds. Cosmic inflation, driven by a strange vacuum energy, the universe suddenly expanded exponentially, increasing in size by a factor of 10 to the power of 26, in a tiny fraction of a second. This rapid expansion smoothed out the universe and flattened it. Quark-gluon soup. As inflation stopped, energy began transforming into subatomic particles. The universe was a seething, hot soup of quarks and electrons, too hot for these particles to combine. Symmetry breaking. As the universe cooled to 10 to the power of 15 K, the fundamental forces separated, allowing for the creation of heavier subatomic particles. 3. Hadron and lepton epochs. 3. Hadron and lepton epochs, 10 to the power of minus 6 seconds to 3 minutes. Protons and neutrons form. At a millionth of a second, the universe cooled enough for quarks to combine into hadrons, specifically protons and neutrons. Matter over antimatter. Particle creation produced equal parts matter and antimatter, which annihilated each other. A tiny surplus of matter, only 1 part in a billion, survived to form all the matter in the current universe. Neutrino decoupling. Around 1 second, neutrinos stopped interacting frequently and began traveling freely, creating a cosmic neutrino background. 4. Nucleosynthesis, 3 to 20 minutes. First atomic nuclei. The temperature dropped to roughly 1 billion degrees Celsius, cool enough for protons and neutrons to fuse. This created the first atomic nuclei, hydrogen, helium, and tiny traces of lithium. Ending fusion. After about 20 minutes, the universe expanded too much for further fusion to occur. 5. Recombination and the first light, 380,000 years. Opaque universe. Up until now, the universe was an opaque plasma. Free electrons scattered light, meaning light could not travel far, making the universe look like a dense, white fog. Recombination. When the temperature cooled to roughly 3000 degrees Celsius, electrons captured protons to form neutral hydrogen atoms. Transparency. Without free electrons to scatter it, light could suddenly travel freely, making the universe transparent. Cosmic microwave background, CMB. This first light, released during recombination, is still detectable today as the cosmic microwave background, CMB, a faint, uniform glow of microwaves bathing the universe. 6. The Dark Ages and structure formation, 380,000 to 400 million years. Dark Ages. Following the release of the CMB, the universe had no stars or light sources, plunging it into a dark age. Structure formation. Gravity began working on tiny variations in density. Areas with slightly higher density drew in surrounding gas, forming the first, massive stars and eventually the first galaxies. 7. Reionization and today, 400 million years to present. Reionization. The intense UV radiation from these first stars tore electrons away from neutral hydrogen atoms, turning the gas back into an ionized plasma. Current era. Galaxies continued to merge and form. Stars died, creating heavier elements. Around 9 billion years after the Big Bang, our solar system formed. Today, the universe continues to expand, and this expansion is accelerating due to dark energy. Now that we know how the Big Bang occurred, let's look at the evidence that supports this theory. 1. The expansion of the universe, Hubble-Lemaitre law. In the 1920s, Edwin Hubble and Georges Lemaitre discovered that almost all distant galaxies are moving away from Earth. Hubble's law, expansion observe.